All right, we need to do a show close, and we're going to see if we can...
Open.
Show open. So Dada said that, I just went blah,
We almost never
regurgitated.
need to do a close. We almost always do a close.
Are you saying that I close the show brilliantly every time?
That's not what I said.
I think that's what she said. Thank you so much for watching.
Yep.
We'll see you next week.
Dada does the close.
The master of fade to black button. All right. We started with Mike. So Space Mike, you'll do something Falcon 9 related. Don't make weird noises. Falcon 9 related. Jared, you'll talk about which one do you want to do?
Let's do Mercury. I really like that.
You'll talk about, I believe the exact line you'll use is, only look at Mercury through the fur of a very small, cute kitten.
Yeah, I could do that. Only look at Mercury through the fur
I wasn't
of a
actually
very
100% sure you would catch that before the show.
I did catch it.
Yeah, I noticed because you
modified
underlined it. Yeah. And then I was like,
when
dang
did you
it.
put that in there? I was just like, if Jared put that in there and he actually says that, I'm going to be like, this makes me not believe everything that you just said.
So for those wondering what's going on, we have show notes, right? Just like things like stats and numbers that when you're on camera in the moment, you're going to forget these things. So it's just like a little cheat sheet, right? It's not scripted, it's just a cheat sheet. And in his cheat sheet, he said, in all caps, which is, I think, the first time in the show notes we've ever had anything in all caps. It says, do not look at the transit with your eyes, sunglasses or welder's glass. Only use solar filters. That's what he wrote. Then I figured, I'll just add on to that. And I said, or through the fur of very small, cute kittens. I don't know.
Which I also know you should not be doing that.
Don't hold a kitten up and look through its fur at the sun.
Yeah, just a disclaimer.
Oh, I'm sorry. Your kitten wasn't cute enough. You get to go blind today.
Exactly. That's right. Yeah, it was like a cuteness scale. I said cute. All right. So I've got no. You've got SpaceX. You've got Mars, and then I'll say
Mercurus.
Or Mercury. Sorry. A planet. One of the real planets, not the dwarf planet.
Pluto.
Yeah, like dwarf planet Pluto.
No. And actually, I saw that tweet. We'll come back to that.
Yeah, we will, because some things have changed. So.
Since the tweet?
What?
What? Now Pluto's a planet again? That's what I read the tweet as. Is basically Pluto's a planet. And you misclassified it, and you're to blame. And then I'll say, and the...
Okay, yeah,
Antares
we'll
Mark II. Antares Mark II, plus a live interview with Dave Dissler about the EM drive. All right, here we go.
Antares rides again.
Antares what?
Antares rides again.
Wait, is it Antares or Antares?
Antares,
I don't know.
Tomato.
I think it's tar.
Potato.
It's potato. Actually, I've never heard anyone say potato. Does anyone ever, like, potato, potato? No. Who says potato?
The English
Who says
do.
tomato? No, the English are
English.
wrong.
It's a British thing.
You're English.
Whatever. All right, here's number one. I feel like we need Carrie Ann in this.
Why?
I don't know. You did the comments. You want to do the main topic thing? It's weird. We don't have enough of your interaction during the show, and it makes me sad. No, what?
It's okay.
All right, here we go. Number one. Coming up.
SpaceX launches JCSat-14 and lands another Falcon 9.
Oh, no, it was me. Sorry.
Plus, Antares flies again. Then we have a live interview with Dave Dissler talking about the EM drive. Stay tuned. Tomorrow begins right now. And you know we're using that one.
Sorry, mine was so wordy. I didn't know how else to sum it up.
My brain shut down in the
That
middle of
was
that.
so wordy. Holy cannoli.
My brain was just like off.
I almost didn't keep going, but I'm like, I can salvage this. Number two.
Hold on, I need to recompose my brain.
Number two.
Did you try turning it off and turning it back on again?
Yes, it's on now.
Number two. All right.
All right.
Coming up.
Falcon 9 launches a communication satellite and lands again.
Mercury transits the sun.
Plus, Antares flies again. Then we've got a live interview with Dave Dissler talking about the EM drive, the M possible drive. Stay tuned. Tomorrow begins right now. That was a little cheesy. Yes, Jared was a zillion kilometers away.
Yes, I was.
Thank you, chat room. That's fantastic.
Thank you. 2.3 zillion kilometers.
Yeah. I won't be talking about that. We'll put it that way. Should we do a third one? Do we want to do one more?
Well, we can do it a zillion times until we get it right.
Thanks, Space Max.
I'm sorry.
Oh my gosh. Oh.
Oh man. Okay.
Yeah, so Mini Storage doesn't like lands again, flies again. Is there a different, instead of flies again? Gets ready to take flight, is ready to take, almost, is about to take flight.
One more time.
The return
One
of the
more
Antares.
time. What? Yeah, the Antares one. Let's change my verbiage. What's my verbiage here?
Instead of Antares flies again, the return of Antares.
And the Antares returns.
Revenge of Antares.
No.
Revenge of the Antares.
Yeah, but Dan,
The
you're
Antares
seeing it
launches
without the
back.
graphics. Like, that's not entirely fair because most of the verbiage is going to be on top of or underneath graphics. So you're going to get, you know what I'm saying? Like, you're going to have picture and then picture and then picture. And then you're going to see all of us and only Ben talking. So the visual is still the same whether or not I talk.
Yeah, returns to flight.
Return of Antares. Just the return of it.
Return to flight. Like, that's the technical.
I know, but return of. I think we got it with the last one, right?
Yeah.
It was cheesy.
It's fine.
Yeah, I think it's good.
Did we want to bring? Should we ping Dave? I feel bad. Hang on, let me check my email. I didn't actually coordinate with him.
Whoops.
I was busy with. I feel bad for Dave because Dave was like, "Hey, I need information." I'm like, "Yeah, cool, I'll send that to you." And then like we're trying to launch a rocket, and so I would legit like it would just escape my mind. I'd forget to send the thing, and I feel bad for him because I just didn't. I didn't get him.
As a new manager,
Yeah.
I've gotten all these like courses that I have to take.
Mm-hmm.
And at the end of the course, once you complete the course, basically to prove that you've completed the course, they give you a little like super cheesy, like if you go to Target and you buy a diploma, a frame that's, you know, specific to a diploma kind of whatever, and it has like a fake diploma in it. That's what these like little certificates look like. And you have the option to print them out. And one of the other managers came by, because we both became manager right around the same time of different areas, came over and was like, "Hey, so I got this certificate, and it says here that I do not sexually harass people." I'm like, that's hilarious. And he goes, "You know what I want to do? I want to get this printed on a T-shirt." And be like, no, it's okay. I won't sexually harass you. And I'm like, actually, that is brilliant, and I totally want to do that because it has your name on it and everything, because it just auto fills in and all that other fun stuff. That totally makes me laugh.
All right, let's see here. Let me find his email. Oh my God, so much email.
I sent him an email. I haven't had a response yet.
Okay,
But
I don't want to bother. I mean,
I'm
I'm
unfamiliar.
taking time out of people's Saturday, and I don't want to just bother them with more show stuff. So, ultimately, what we need is that 4-channel Skype unit so that we can have Mike on and have Dave on, and not have to do this weird shenaniganery. And then, by the way, once we get that, I do want to get to a point where the opens are pre-made. I mean, done live, and. What? They're done live. They'll be done live. And it's a cohesive show that starts and finishes, and we just pop that into the Googs when we do our opens live. Actually, we could do them live, except for this one.
Can't help it.
So what'd you guys think? Was that an okay show? Yeah, I miss having guests on. It's so nice to have guests. It's just a good change of...
It's pretty cool.
Yeah.
Absolutely. I thought that was awesome.
Yeah.
That was really cool to get some more info.
It's really great to have guests that, like, are actively doing things, right? They're not just talking about like theoretic. Like he's like, no, I'm building it. In fact, here, I'm building this, right? I thought that was pretty awesome. What we need to do is we need to bring him back on after he's done with that and be like, how'd it go?
Mini Studs wants him to read audiobooks for her.
Yeah, he has a great voice, doesn't he? Yeah.
It's pretty cool.
Absolutely.
Nice.
I mentioned that like in the pre-show, like he said hi and he's in my ear. I'm like, whoa, hey, you've got either a good microphone or a good voice or both.
That's awesome.
Yeah, so if we did the open during the show, we could reduce some editing. You're assuming that it would only take one take to do it. And if anybody has ever watched us do these, it always takes more than one. So, yeah, in theory,
Not always. We did it in one take when Ben wasn't here.
We'll do it live.
we did it one take, yeah, when Ben wasn't here, all of once, right? So, yeah, I mean, I guess in theory, you just keep going until you have the good open, and then you just start the show immediately from there. Theoretically, but that's still some editing anyhow, because we still have to put the music on top of it no matter what.
No, the point is we wouldn't do that. The point is it'd be a cohesive, like the intro, all of it, music, all of it would be done. We'll work on that for season 10. We'll try to get that for season 9.
But we definitely would have to, yeah, well, then we're not doing those live.
Well, yeah, I think.
Pre-doing them is different than doing them live.
Yeah, I mean.
Doing them live is like.
We're totally going to do them live. Yeah, so we'll. It will all be live. Yeah, so we'll just record it. And
like
roll
this
it
is
in.
live right now.
Yeah,
It
exactly.
reminds me of there's a Family Guy episode where Peter sneaks out and Lois walks in, but Peter wrongly anticipates the questions that Lois is going to ask. So he has like the tape recorder and the whole thing. And she's like, why are you getting so mad, Peter? It's like she's not saying the same things that he was anticipating. That's what that reminds me of. Anyway, sorry.
Well, we have Dave Maston on as a guest this year. When we get the new studio of tomorrow.
Well, wait. There's a couple of things going on. We have to get into our new studio of tomorrow, and he has to, I don't know, get married. So we're all a little busy.
Oh yeah, how long
at the
until that
moment?
happens? He's getting married at the top of Mount Everest, I believe. Last I heard.
I thought it was Vallis Mons.
Well, sure. That's closer.
His plans for world domination are much further accelerated than you previously thought.
No. You know how, again, I've said this before, I'm going to say it again. He probably pisses him off that I say this. You know how, like, out of nowhere, Blue Origin was just like, by the way, here's a rocket. By the way, we flew it again. By the way, we're going to do humans soon. It was just like nothing for a decade. Nothing. And like, oh, we're basically done now. I'm pretty sure that's how Dave Maston's going to be. He's going to be just like nothing, and be like,
by the way,
here's my lunar descent module, and it's going to go on this rocket that is reusable, and next week, cool with you guys? Great, it's human rating.
Sweet.
Pretty
Yeah.
sure that's what's going to happen.
Yeah.
Pretty much.
So Vac says Dave would probably be down to come back for After Dark. You want to ditch Mike and ping him?
I always want to ditch Mike.
Okay, bye Mike.
Oh, that was cruel. Oh, that was just mean. Oh, we're sorry. I'm sorry, Mike. It was so it was mean, but it was fantastically hilarious.
Oh boy.
Could we get someone from NASA to talk about the Space Launch System? Maybe. I feel like they need to say positive things about the Space Launch System. That's harder to do.
Yeah, that is very difficult to do.
Thank you to Structure 1701. My lowest is decent at best, and I maybe get a line or two in. That's decent, but that's about it.
About what did he say?
My lowest impression.
Oh yeah. It's pretty
Lois?
good. Yeah.
From Family Guy.
Oh.
Burpy derpy doo.
Yeah. There was something that was said that just reminded me of. Oh, because we were talking about doing the opens live. And
We'll do it live.
And it just, I don't know, for some reason it seemed to me, because there's sometimes that every once in a while we just like skip over a topic, or okay, I don't know what's going on anymore.
I am too, so confused.
My elbow slipped.
I am here.
Yay! Welcome back,
Awesome. If you
Dave.
could hit the button. Right now you're this floating
Voice, nebulous
thing.
voice.
Yeah, do you want video or just audio?
If you can do video, that would be awesome.
Okay.
It's not required. I mean, it's mostly required. It is in fact required.
It's-
Thank you
Take
for
my
coming back.
glasses off Sure.
Thank you for coming back. You know, I normally coordinate that before the show. Be like, hey, do you have time? And then it just slipped my mind. So, by the this is totally casual. There's no anything. So
We're just hanging out.
We're just hanging out. If you ever like, I'm done, you can just be like, I'm leaving, and that's cool, right? So just so you know.
All right.
We do have some more questions, and I'm just going to go straight down the list, if that's all right.
Yeah.
But there's no context anymore. So we'll see how this plays out. Space Cadet 88 says, question, does the interior cavity need to be a vacuum?
It's being tested in air right now. No, it doesn't need to be. There is, in a vacuum, it's going to be close to the dielectric of air, which is 1. So in a vacuum, technically, it should work. There's been some discussion about having a variety of different gases in there that would enhance this effect. They've been talking ammonia gas. They've been talking, which is, I guess, used in masers, microwave amplification by stimulated emissions of radio, something, whatever it is. They are talking about using other gases in there, but as it is right now, no, you could put it into space in a vacuum and it'd be fine.
What is a maser? Is that like a microwave laser?
Microwave laser, that's correct.
That's kind of awesome, actually.
It's like a word that you would make up.
It does. It sounds a little bit like a made-up word.
Ben likes to make up words.
Yeah, no, it's actually, if you look it up, do a Google search on it. A maser is basically an energy weapon is what they first started out, but it's it uses the same principle. You put microwave radiation into a tube filled with, I think, ammonia, if I'm not mistaken, so it bounces around and then shoots out just like a laser does, only you get some really high levels of radiation coming out of the thing.
Now I want a maser gun. That would be awesome.
Yeah, close to
Yeah.
close to phaser. I
Phaser.
think, yeah, right?
Oh yeah, it's like a phaser, but a maser.
Yeah.
All right. Icarus Factor. Is it using the Casimir effect? I don't know what that is.
Casimir effect is a lot of people think it is. That is a I'd almost want to say down at the atomic level, but it's when you have two plates, metal plates, they will exert a repulsive force out like this. The problem you get into is what is one plate pushing against on the other, and can you have a Casimir effect on something with 8 inches of plate separation, with the plates being conductive with each other. The Casimir has different polarities, I believe, has different polarities on one plate versus the other, and so they're not in physical contact nor electrical contact. So it's possible that the Casimir effect is part of the reason this thing seems to be moving.
Yeah, he continues on. Instead of plates using microwaves moving fast enough to control pressure. So, all right.
Right. Yeah, that's a good question.
Heldesk, how do you prevent, Heldesk states, how do you prevent the resonant cavity changing shape due to temperature and ambient pressure changes if the walls are as thin as those?
Yeah, here's one reason. I used a much thicker, rather than that mesh. I don't know if I can show this to you or not. Look down
Donna,
the,
can you go full screen?
yeah, go down the business end of this frustum. This is a 1 mil thickness piece of copper on the frustum. Okay, and then on the outside of it are brass rings, which will be, soldered into place to help hold its shape. Now, 1 mil of copper is not going to deform much, even if it was exposed to a instantaneous vacuum. There will always be thermal issues. But it would have to change shape the way the magnetron's frequency is, because it's splattering RF all over the place. It would have to change substantially to be outside the range of the center frequency of the magnetron. The magnetron operates, not to get too technical about it, but it operates plus or minus 30 megahertz, and you would have to really deform that thing to make the cavity go outside that frequency band.
Space Cadet 88 asks, and this question actually doesn't make sense to me. He says, as a non-scientist, wouldn't there be movement of the flashlight in the opposite direction from the beam? But we're talking about, we're using photons to create energy. We're not necessarily using, so I'm not sure. Maybe you understand the question better than I?
Yeah, it's still you've got a reaction mass. So what'll happen and the mass is so small with the light photons that it's going to throw them out, and the reaction is going to be there will be a slight movement. Okay, so as it throws out the photon energy, you will have an equal and opposite reaction of the device, which is what you want. You want it to move. So, but it's so vapor thin of mass that it really doesn't do anything by itself. What a lot of people have been talking about is a collimated photon rocket, and what that is a combination of a stationary target that fires the beam, very much like you had with that one Orion project where they were blowing up the spaceship at every 10 seconds or something.
That project was crazy. It was awesome, but crazy.
Yeah. So you've got this thing actually firing, and it's what Hawkins is talking about from an Earth-based, ground-based system is firing this beam up and actually displacing. That is what people are really talking about when it comes to photon rocket technology. That is available right now. Why they haven't tried it is probably what you mentioned earlier, is the cost of launching this stuff. So.
Also, a photon rocket sounds awesome.
It does.
Just a photon, just like I'll be going to the moon on the latest photon rocket, the Boeing 777 Photon.
Yeah, that's right, and just one step away from a photon torpedo. So it's all.
Yeah.
Hey.
All right, you're right there with the Star Trek. Neuropilot. Go ahead. Yeah. Oh yeah. Neuropilot question: a 2.4 gigahertz magnetron resonates atomic hydrogen? Question mark. Right, and there's some atomic hydrogen in deep space. Am I right?
The atomic resonance of it's close. It's the resonance of 2.4 gigahertz is actually H2O. That's why a microwave oven works. It excites the water molecules in whatever you're putting in it, and gets them to moving real fast, and that heats up the cup of coffee or whatever you got in there. Of pure hydrogen or I think the question was nitrogen. To my knowledge, it is not a resonant of the microwave frequency itself. It's not a resonant frequency band of nitrogen itself. But there is a lot of nitrogen and hydrogen all over the outer space. The issue is how's a closed system interacting with the outside world? Outside of these frustum walls, it's got to paddle or swim or corkscrew or whatever with something outside. And that's kind of the conundrum everybody's in right now with this thing.
Because there's no expelled propellant. So
right.
What the heck?
Mm-hmm.
Destructor 1701. Oh, you mentioned this earlier. He asks, what are S-level standards?
It's varied. Last time I was involved in it, it's probably been about 15, 18 years ago. There's a lot of different standards. First of all, it's got to operate in a vacuum, or it's got to be in an enclosure that is vacuum. If it's got to have air in it to work, then it's got to be in an enclosed, and it can't leak. Something they call fine leak. They actually dip it in this, not water, but regular chemicals, and they pressurize it and see if there's any bubbles that reach out. That is something that, in my experience, we had to deal with. There's also something called PIND, which is particle impact noise detection, where you actually shake it, and if you hear any particulates moving about in there, then it's going to fail somehow, because one of those particulates might be metal that'll go against a connection. Zap, you just lost your satellite. But the main thing that I've always been associated with the S level is shock and vibration, impact, shock, and vibration. This thing, you actually put a device, the stuff I used to work with, you'd put a device on a large sledgehammer, and you let the thing fly, and if it worked afterwards, after you did it X amount of times, then, hey, okay, it's space qualified because it handled 10 Gs of impact vibration. So, go ahead.
That sounds kind of awesome.
It's fun stuff. I mean, you gotta blow stuff up and mash stuff and everything, so that's pretty cool.
Why are you blowing that up? I need to qualify it.
Well, there is something called destructive testing, and if they really want to push it to the limit, they have something they call destructive testing. As I am going to find out where this thing fails. In other words, they're not giving you like, okay, this has got to have it's got to survive 20 Gs. I want to see where it blows a gasket, and
Have the fire extinguisher ready.
and they'll run the test until it does. And if it takes 100 Gs to do it, it takes 100 Gs.
That would create an energetic. The higher that number, the more energetic event you get out of it.
Yeah, energetic event would be
Yeah, actually, I think we've talked about this in the show in the past, but destructive testing is actually very useful. Turn it to 11. If it doesn't blow up, turn it to 12. If it doesn't blow up, turn it to 13. Keep going, because then you know the exact upper limit of the unit. You know exactly how far you can go. So even if you qualify it for substantially lower than that upper level, if there is a scenario in which you need to crank it to 12, yeah, we were able to do that on the stand. The downside of that is when you're working with in aerospace, you're working with very large engines. Let's just say you're working with an F1 engine from the Saturn V. Cranking that to 12 may not be the best idea.
no.
When it decides that it no longer wants to operate, the energy released will be massive. So
Head for the hills. That's a good way to put it.
Although it seems like an EM drive, you should be able to crank it up to 12, like something like that. You should be able to crank it up pretty high, and it wouldn't be.
Yeah, the only thing that really would prevent that would have to be modified on this design that I'm doing is the attachment of the magnetron. The magnetron's actually it's 750 milligrams of weight, so it's not a small little thing. It's that's the RF source, so that's hanging on the end of this cavity. And that's going to give a lot of momentum, away from whatever is holding it down to that cavity. So you really have to do a lot more. Like, for example, I solder torched mounting studs on there. Well, you're not going to do that for S level. You've got to braze it. You've got to use the proper type of metal, the titanium as opposed to what I was using, which was copper-plated steel. A whole different scenario. Nothing that I haven't dealt with in the past, but it's a different animal.
So, you didn't really let me gather my words here. You're using RF here, so you are radiating, which means if you were to turn this up, would you be adding more RF to it? I mean, could you?
Yeah.
You could actually. So then, the energy released would just be in a different form. You could actually create quite a bit of harm to a human if you did it wrong. Right?
It is very, and I meant to say that during the regular show is that this has a double whammy, so to speak, if you're experimenting with it. First of all, it's got microwave radiation, and the radiation itself has to be contained. And unfortunately, if you know how to build a electromechanical cavity, which I've done many times, then it's no problem. You know how to shield and guard from leakage and things like that. So you don't want anything that's inside that sneaking out. And think about it, since it resonates at H2O, water, your eyes are actually the first thing that can really be damaged by getting a magnetron and just sitting there and looking at it and turning it on. I mean, that's real serious. You don't want to mess with it. So if you haven't dealt with microwave equipment whatsoever, don't even try this. Don't disassemble a kitchen magnetron. Number two, the other part of the double whammy is really the voltages. The voltages on this magnetron are 4,000 volts, 4 kilovolts. Enough to be very lethal, very painful. It'll burn you faster than it will do anything else. But give it in the right circumstances, you put your hand over this and you don't get your hand off fast enough, it'll stop your heart. So you don't want to even, there is a reason. You remember those stickers that are on back, do not open this, electrical shock? Most of them are, so what? This one you want to really pay attention to because it's 4,000 volts in a regular kitchen microwave. Just don't mess with it.
Yeah, just like you don't want to take your microwave apart, you probably don't want to. I mean, you've got over 35 years experience in this field. This is what you did. So you experimenting with this drive makes sense. You know the safety precautions. Chances are basically everyone watching this show does not have that same knowledge base. So while it is cool, you probably should leave it to the experts. And instead of building an EM drive, I would suggest a Project Orion drive. That seems...
I'm going to try it.
No.
Yeah. Try launching some small nuclear. I don't know how would they make something that small of a nuclear bomb. See, that's very curious to me. How you would, because what was it? The big bomb that they used in the World War II, the monster thing, weighed a ton or more.
But we don't have, so in the video, we don't actually have context to its size is the other thing. Although some of the earlier things, they were only, they're about, it's hard for it to tell, but they're about yay big when you look underneath it. Yeah, so
okay.
The other thing is, I'm not sure that is actually, that could just be an explosion underneath it.
Those
right?
are just explosions.
Yeah, I don't think that's actually
are they?
like,
okay.
I don't think they're radiating there.
Let's hope not. Although there's not much vegetation around there, so maybe.
Potentially.
I don't know. Maybe someone from the chat room can answer. I don't actually know if they did test with a nuclear well, it'd be a bomb at that point. Someone let me know if they ever got to that point in testing. I know they did a series of tests.
No, absolutely not.
Okay.
Yeah,
well,
they never got to the point
That's
of
interesting.
using a nuclear test for a Project Orion test vehicle. So
wimps.
Yeah. What's up with that?
Yeah. All right. Moving along, Johnny Boy asks, would EM drive benefit of superconductivity due to low temperature in space?
Yes, it would. The more the lower temperature that you have, the better conducting it would be of electrons and potentially copper ions within the frustum itself. So yeah, the colder the better. And there's been a lot of weird stuff on the internet about superconductivity and what it can do. I think the ultimate is get your hoverboards ready, because if you can get something that's room temperature and superconductive, you've got your hoverboard, you got your flying cars with that technology.
yes.
Boom!
That's what
Back to the Future coming true.
Lexus made that hoverboard that actually works on metals. They built like a hoverboard skate park where they had a whole bunch of metal underneath that could superconduct.
Yeah, that's right.
But they had to have liquid nitrogen inside, like in the reservoir in their hoverboard, which made it cool because there was like the
literally
outgassing of liquid nitrogen coming out of it as these guys are riding around, and it was really cool.
I thought the smoke was really cool, but it was just a side effect of the liquid nitrogen or whatever. But that was pretty cool.
All right, so that's everything that I had in the. I'm sorry. 3Zool says, how precise do the measurement need to be to notice the EM?
Was that Alexa?
Hello.
Yeah.
I'm sorry. How precise do the measurement need to be to notice the EM drive effect?
You can do it at home. It's not easy.
But don't do it at home.
Yeah, but don't do it at home. Yeah, I got to keep remembering to plug that. The end plates are polished to about 1 or a half micron flat, and I did that myself. Talking to a guy who used to do it up here, and how he did it with a lapping wheel and everything. And boy, it was all manual. It was all manual labor. So I spent quite a few hours out there getting that nice and flat, and then did the 0.5 micron polish on it and everything. So I'm pretty comfortable with that. So that's one of the things I tried to do to actually scale this up. Okay, let's make this thing more accurate. I'll also be polishing the inside, not the end plates, but the inside of the frustum. You're probably looking at about 1 micron there. The overall length variation doesn't matter too much because, like I say, the RF energy is so wide, it'll go and resonate in that cavity, even if it's a millimeter off. But what I was trying to get is perfect, and it's not optics because it's RF, but perfect reflections. The end plates are just perfectly aligned. The ultimate would be obviously getting something like 100 angstroms of flatness and 100 angstroms of alignment. We're talking. If you can scale it up, I think that particular alignment will get you the higher millinewton force levels because everything's aligned properly. That's what makes the Hubble work. That's what I think might make the M drive work better.
Destructor 1701 asks, does the EM drive need to be external to the spacecraft, or is the thrust just as self-contained as the microwaves? It's an interesting idea. Put it inside the spaceship. Although, yeah.
That's a he's got a couple of good questions there. Theoretically, which I'm no genius in that by any means. I would say that if you are interacting with something in the quantum world, it doesn't matter if it's inside the spacecraft or outside. You would definitely want it on the outside because of the exposure to the colder temperatures. That's a big plus, I think, for the M drive. The potential leakage of radiation for crew safety, I think, would be best to have it on the outside. And for whatever interactions it's having, either at particles or waves in this quantum universe we're dealing with here, I do think it's best to keep it out in its natural environment, which would be space itself, and don't let it interfere with any other, something that may stop particles or waves from getting to the drive itself, if that makes sense.
I think so. I mean, it seems interesting that you could have, theoretically, you could have the engine, because it's not propelling anything,
Yeah.
in the middle of the spaceship.
Yeah.
And still pushing it. That's just, I'm having a hard time wrapping my brain
Put
around
it
that.
put it in the crew galley, right above the table where everyone eats.
Where
at.
everyone's eating, yeah.
So.
That sounds like a great idea to put a lot of RF. Yeah.
Yeah.
Well, you know what the side benefit to that is? The side benefit is you can walk over and put a cup of cold coffee.
That's what I'm saying. It's a heater. It's good
That's
stuff.
That's how you get your Earl Grey tea to be hot.
Yes.
Yeah, that's right.
So that's what it was.
Boom! I got a Star Trek reference in.
Good job.
Boom! What is the, again from Destructor 1701, what is the Q value that everyone talks about in the thread? I assume this is one of the NASA spaceflight threads.
Right. Q value is simply a ratio of bandwidths, depending on how you're taking the measurements. It stands for quality factor, and without throwing a bunch of numbers at you, it's really how the cavity reacts and allows the photons to resonate in the cavity over what particular frequency band. So the Q is, just look at it as a quality of it being able to handle and not attenuate. Here's probably a better way to put it. You're ringing a bell. If the bell is made out of some real cheap stuff, it's going to go clunk. If it's made out of some really fine bronze, it's going to really ring nice. It's sort of the same concept. You got better Q electrically with a well designed, polished frustum M drive. Yeah.
Johnny Boy asks, could it fit in a CubeSat?
No, that's the unfortunate thing. But there is for Johnny, I would say write this down, because there is a CubeSat M drive design going on right now. It's in its second generation. It operates at 10 times the frequency. It's on Hackaday. If you go onto Hackaday and you look for baby M drive, there's a guy in Aachen, Germany, who is specifically designing it for a CubeSat application. And that is small enough to go in its CubeSat is what? Something like this in comparison to, the frustum itself on 2.4 gig is like 10 times the size.
That's an interesting concept. So if you had if your rocket could get you high enough up with enough velocity, and then you had a CubeSat with an M drive on it, and
Yep.
it had enough oomph on it. That's a technical term instead of saying delta V. I like oomph better.
I do too.
You could use you could use that to do interplanetary missions in theory. I mean, you got a lot of ifs, but you could. I mean, that's one of the problems with CubeSats right now. Is most of them don't have very good propulsion, right? They go up, they go around Earth, and they come back.
Yeah,
It's just kind of like up and down, and even there was a Planetary Society launch of a space sail that was just a concept type of thing, and they spent that money on that space light sail, and I don't know that it stayed up there but a few hours. But ideally, what the guys in Aachen, Germany, are trying to do, and I forget Paul. Well, his name is Paul. I forget his last name. He has built CubeSats before, and he took the M drive and put it on a higher frequency, which reduced the size because the resonance goes down, and it's CubeSat capable.
That's kind of. I assume everything goes down with it, right? So The amount of thrust available goes down. The amount of power required probably goes down as well.
Right.
Smaller wavelength, I assume.
It is scaling everything down, but to get something up into space as cheap as you can, doing a CubeSat would be the way to go. I think he's got a great idea. He's measuring some very, very small thrust forces right now in his second generation. But if Johnny goes on to Hackaday and then does a search for baby M drive, he'll find him.
That'd be really cool. Is actually seeing if it works at all, right? Because it's still.
Right.
I mean, we kind of glossed over this. We still don't actually know that this is real, right? I mean, you're fairly convinced. You're above 50%, but it could all be bad measurement. I mean, we don't know. So let's just assume it's real, and let's assume you could scale it down to a CubeSat. That could be a really interesting application for CubeSats.
Yeah.
All right? Because now we can
Absolutely.
actually very inexpensively send instrumentation to Venus. I know that makes you happy.
Yes.
Right? We could go send instrumentation to Mars, but we could do it privately. You don't need to have these huge, giant budgets. You just go up with the CubeSat launchers. What are they called? I don't remember their name. NanoRacks. Something like that.
Yeah.
Right. Right.
All right. I ran out of questions in my room. You guys have anything else?
Well, we do.
I think it was
have
pretty
that.
well
Okay.
covered.
Oh, we
So-
have a thing.
Okay.
All right.
Yeah.
Any last before we go for the day? Again, thank you for taking so much time out of your Saturday. I really appreciate it.
Sure, no problem. I enjoyed you guys. So maybe we can get back together after my testing is done, and I'll kind of
Heck yeah.
update you
Yeah.
on that down the road a little bit.
Totally.
Get in touch with me, or Vax will get in touch with me. Whatever you want to do. I enjoy it. Hopefully, it was informative to your audience.
Oh, it was great.
Yes.
It was much better than our last attempt at the EM drive. Let me tell you that.
Yeah, that's for sure.
Yeah. I would love to bring you back on as soon as you have some more data and talk about what you found, and good or bad, right? I mean, that's kind of the
Yeah, that's
scientific
right.
process. Yeah, absolutely.
As part of the process, and my goal is to increase what I saw. If I can't increase what I saw, then there is a pretty decent chance that what I saw was some sort of thermal errors. Lorentz force, could be a lot of different things, but we'll see.
It's exciting. Like I said, this could change
Yeah, it is.
everything.
Yeah.
All right. Thank you so much. Everyone else, that's our show. Thank you for watching. I hope you guys enjoyed After Dark. We'll see you next week, and have a good day.
See you guys.